My name is Tim Growney. I am a senior engineering manager at Teespring by day. By night, I am co-founding a company to try to solve the surplus medical supply problem that the United States experiences every year. And of course, that's being built on top of serverless. But I'm not actually here to talk to you about that. I'm here to talk to you about my hello world experience with serverless. So when I first started working at Teespring, we had a problem. There were 30 people to a single toilet. Now, I don't know about you, but after lunch, when your eyes are getting a little droopy and it's kind of settling in your stomach, then you need to go get that cup of coffee. Then you go back to your desk, you drink your coffee, and then as coffee does, you get that sudden urge. So at Teespring, this was almost a daily experience for me. So I would get up and it'd be a coin toss. I'd walk into the bathroom and maybe I'd see feet under the stall, maybe I wouldn't. So at that point, you kind of let out an audible sigh and you have a choice. Either you stand there and wait and hope that they don't have too many Scrabble friends, or you go back to your desk and you listen for the door to open and close. So after about a couple of months of this and being on the receiving end when you're actually in the restroom, hearing somebody walk in and giving a sigh, I started to actually think about, okay, how do I actually solve this, right? Like what kinds of solutions? I'm an engineer, I can do this, right? There's something that I can put forth that can actually solve this problem. So I started thinking about it and I was like, maybe we can put a light on the door, but then people who are on the other side of the building can't really see it. There could be some kind of like key card system. There could be something that we could use to put in place to actually fix this problem. So then Teespring actually forced my hand and they did an internal hackathon project where we could fix anything about Teespring that would make things better. Now, I don't think that they had this in mind when they actually gave us those parameters for the hackathon, but I went ahead and did it anyway. So a couple of things that I actually sat down and did were, or a couple of the requirements that I actually set out were, it had to be hands-free. I didn't want anybody touching this with their dirty fingers. It also just had to work. I'm sure a lot of people in this room have actually built something that wasn't meant for production that goes into production, and if you built it, you own it. I had to be able to check it anywhere. So from a conference room, from the top floor, from the basement, even sitting on the bathroom, just on the toilet, just to QA the thing. And then it couldn't be too weird, not any weirder than what we were already trying to accomplish. So I started thinking about solutions for this thing, and I thought, okay, well, I don't think keycard access or anything like that is actually going to work. So what I'm thinking about doing is actually just like some sort of electronic switch, right? Something that is an indicator that nobody can actually touch, that just gives me some way of actually telling, hey, there's somebody in the bathroom. And so I went back to high school physics, and I was like, okay, well, there's some sort of concept here that we can use. But what do we use as the switch, right? So I was thinking about that, and there's ultrasonic rangefinders that we could use, but just because it's ultrasonic doesn't mean it doesn't actually emit a sound. So sitting on the toilet with a clicking sound is probably not very much fun. There's IR sensors we could use. There's some sort of switch that we could put in place on the door, but then we're running a ton of wires, and that's not a lot of fun. So I started thinking about it a little bit more, and I thought, hey, okay, well, the other component to this is we probably need some way to actually talk to an endpoint, like a web endpoint of some sort. So Raspberry Pis actually fit this really well, because what they have is they have input-output ports, and they have a 3.3 volt output where you can actually detect a logic high or a logic low. So that's exactly what I put together. Pardon the crappy tape. So, and I'd also like to point out on that middle picture, this problem actually had an attempt in a previous hackathon to solve this. by the business team who thought that throughput could be improved with a squatty potty. So our end result ended up being 2 wires running from the Raspberry Pi, as you can see, and running to the receiving end of the lock, and the wires were air-gapped. So what I did was I trimmed the ends off of the wires, I solder tinned them, and then I taped them in place. And before that, I actually ran a continuity test on the lock rod here just to make sure that, oh, hey, by the way, it will conduct a current because the materials don't allow that. So lo and behold, you can actually close the door, close the lock, and the circuit is closed. So I was actually able, within the Raspberry Pi code, to detect whether there was a logic high or a logic low. So then the next question was, okay, well, what do I do with that information? So the nice part about the Raspberry Pi is it's running the Raspbian Linux distro. So I could actually tap into that, hook up to the Teespring wireless, and actually hit any web endpoint that I wanted to. So the code was actually really simple. We set up a read port initially, we initialized it, and then we polled every 5,000 milliseconds. And then if it actually read a logic high, it would send off a request to one Lambda endpoint. If we read a logic low, it would send another request to a Lambda endpoint. And this is all built on Node.js. When the Raspberry Pi resets, as part of its startup, it would actually go out and just run this thing. So if anything failed, I could turn it off and back on again, and it would just start working. So for the actual serverless concept, I needed some sort of glue for the whole system, right? I needed something to be able to take that message and actually store it in a way that I could display to my users, particularly myself. So one of the things that I wanted to try to do was stay away from any sort of data store of any kind. I didn't want to spin up a database for this thing. I didn't want to have to maintain any sort of backends, anything. I wanted it to be stress-free. So I ended up using the serverless framework in conjunction with S3 to be able to just update this thing every 5 seconds. So what I could have done was actually gone out and just written some Lambda code and then hook up an API gateway to it and call it good. But I only had 2 days to do this thing, and the serverless framework actually makes it super simple to set up. So from a serverless code perspective, it was really easy. We have a serverless YAML with 2 endpoints, both get endpoints. Again, this is really crappy code. And then the handler actually just had an S3 connector that I wrote, and it updates the status file, which is a JSON file stored on S3, that allowed me to actually just set whether it was busy or not, depending on what the Raspberry Pi actually said. So then we had some static S3 page code, and I wanted it to be super simple, lightweight. Didn't want anything, I realized there's a typo there. I didn't want anything to actually impede just pushing this thing constantly. I didn't want any backend servers or anything like that. So the index.html was simple. The biggest part to the whole thing was just actually performing an XML HTTP request to the actual status object on S3. And I pulled the data, I pulled the state of that status object in, and I was able to display it. And so there's your status page. So this was set up on canigoyet.teespring.com. So it was answering the question of whether or not I could go. And I actually modeled it after isitchristmasyet.com. Yes or no. You receive a big Christmassy yes if the bathroom's open. It gives you a last updated where you can actually tell, hey, this is the last time that the Raspberry Pi actually hit that endpoint. And then it also gives you the current time in the restroom so that you can actually time it. My luck usually ended up being at about 9 minutes. Legs started to go numb, so I could start to time it so that I could actually hit the restroom at about 10 minutes. We also had a Mac OS app. So there was a system tray icon that also allowed you to query the same input or query the same status file. And there was a gotta go mode. So it would actually flash in all of the Teespring brand colors until it was free, and then it popped up with a notification on your desktop when it was actually free. So anecdotally, my teams were a lot more efficient. They were able to actually get their work done, and I saw every once in a while I'd walk by somebody's desk and I'd see this screen up and running. The one time it did go down, I actually had a flood of requests on Slack to go fix it. So I know that that was at least successful. And I was able to check it, and my life, well, it was a much bigger relief for me than really anybody else. So, and that's really all I have. Is there any questions about implementation? Anything that I can kind of walk you guys through? Sure. Can I upgrade it to be a Slack bot? Actually, I only had 2 days, but that was a thought. There were people who wanted to put a queue in place too, so we could tell, how many people are waiting. Well, if you think of anything for later, I'm at tim.growney@gmail.com. My personal blog is timgrowney.com, and then that's my LinkedIn, so feel free to reach out.